Hey folks, I'm Demotro and welcome back to my combo class bonus channel. Today I want to tell you a few things about percents, or also known as percentages, partially to give you some tips and tricks to use in our modern society where these are a quite common thing, and partially to unveil why they're really secretly kind of a mathematically foolish and dumb concept at heart. They aren't really very logical at the heart of existence. We just happened to fall into a system where they're very common. But what do they really mean? Well, the name is percent, and that tells us a lot. This per is the same per as a word that you'd use if you said, like, there's one bed per person in some house, or I eat 3 meals per day, or something. And cent is the same word root in century for 100 years, or in what you call a penny, the currency that is a cent, or a 1/100th of the next bigger unit, a dollar. And we can see in this name that percent tells us it's going to relate to per hundred, or perhaps hundredth. And if we see how it's commonly used, like if we were asked, what is, say, 16% of 75? What this really means is, what is 16 times a 100th times 75? And that'll give us the number that you put this symbol after. So we'll first notice that this tells us if we ever want a percent of B, that we're really just multiplying A and B and dividing by 100. This always equals A times B over 100. And it also means that A percent of B is the same as B percent of A, because that would also simplify into B times A over 100. And sometimes this will help us out a lot, because 16% of 75 might sound a little hard to calculate at first. How do you figure out 16% of a random number? But it's going to be the same as 75% of 16. A percent of B being the same as B percent of A. And that's a lot easier to calculate. We know 75% means 3/4, and 3/4 of 16 would be 3 times 4, or 12. And that 12 we get by solving 75% of 16 would also give us the answer to 16% of 75. So if we ever need to calculate a percentage quickly, it can be handy to see if they're easier in a flipped form, and if they're not, you might have to multiply the two together and divide by 100. Except in some cases where we get lucky, like 75% of something was so easy instinctually, because 75 over 100 simplifies real small down to 3/4. They have a pretty large factor of 25 in common. So if we ever have a number with a large factor in common with 100, that's going to simplify down pretty nicely. But we don't always get that lucky. We don't even always get lucky on this scale that a percentage hopes to capture, because by aiming for hundredths, we're aiming for numbers that this equation is going to end up with not only some whole number or something easy to fractionalize from a whole number, but also almost hoping that it doesn't end up in a multiple of 10. And that's because although a multiple of 10 is easier to calculate percentage-wise, or as a result from a percentage type equation, if our answer ends up being something like 60% or 40%, that sort of tells us that hundredths were trying to do too much. We could have been naming them after tenths, and that would have worked just fine. Sometimes the percentage is simple enough, like 60% or 20%, that it would have been okay to describe in some tenths-based system as opposed to a hundredths-based system. And other times, it's something that would have been better in a thousandth-based or smaller system, such as if we have to say something is equal to 12.5% to describe 1/8 of something. That would be easier if our system had been named after thousandths of some form and we said it was 125 per mils or whatever. And yes, mil is the word root for 1,000, although it does sound like it would be the word root for million-based things. Word roots can be silly and funny. But when we're looking at how all these systems aren't always optimized for the right size, it becomes obvious that it could be easier to just describe these percents as point and whatever fractional quantity we're describing. Essentially, what the percent is 100 times bigger than we're actually describing. Because this 12% that was the answer to either of these can be called just 0.12 probability. We can say that something has a probability of 1 of happening if it's certain to happen. Something has a probability of 0 of happening if it's impossible to happen. And something can have a probability in between those if it's some other thing, such as 0.12 representing what we might know as 12%, or basically a 12 out of 100 chance of happening. And in this case in our system, it took 2 decimal places to describe. But then if I had something like 10%, I could just say 0.1. And if I had something more tricky like 0.125, which is 12.5%, then I use exactly as many digits as are required, without it sometimes being a round percent, sometimes being an even rounder percent by being like 10% or 50%, and sometimes being a less round percent like 12.5%. It seems that the percentages only sometimes happen to be on the right scale we want to describe, that something was too detailed to describe with just tenths, but not detailed enough to need thousandths to describe. And by just using a more probabilistic definition where we describe things as a decimal or fraction in between 0 and 1, it seems not only clearer because we don't have an additional term to keep track of, but it also seems better fit to all the different possible sizes of detail we might want to describe with something like this. And when we're looking at percents as hundredths, we not only get into a problem with the size not being optimized, we also get into a problem that hundredths are only applicable in this case because we use a base 10 system. And that would be a problem with writing things as decimals as well. So perhaps we should just write the probabilities as simplified fractions. For example, this is 1/10, this is 1/8, and this one right here doesn't simplify quite as neatly, but 12 hundredths does simplify down to 3/25. And these would all be slightly more fundamental, less base dependent, less size dependent ways of possibly describing the chance of something happening. And the base 10 system causes problems when we get up to hundreds, even more than it causes problems with the number 10. Because when we're using the number 10 a lot in our system, that's using things that are 2 times 5s in disguise. Multiplicatively, 10 is really 2 times 5 as its prime factorization or multiplicative structure. And taking something that we need to multiply or divide by a 2 and then a 5 may be occasionally applicable in life, but not as common as the fundamentalness of dividing something by 2, then 2 again, or by dividing something by 2, then by 3, or same with multiplying as those. 2 times 5 is a little arbitrary, but that's the base we're stuck with. And when we get down to something like hundreds or hundredths, it's built by even more 2's and 5's. 100 is 2 squared, and I'll write both of them out here, times 5 squared. So when we really look at describing something that is in terms of hundreds or hundredths, we're describing its structure based on a pair of 2's and a pair of 5's without anything like 3's being allowed in the mix. And so if we look at something like taking one of these fundamental numbers like 0.12518 and turning it into what number we would put the percent sign after, since we need to essentially multiply one of these by 100 to set it to the place where a percent would describe it, we need to multiply one of these true fundamental probabilities by 2, then 2, then 5, then 5. We've come up with a system where to describe the probability of something, we often take the real probability of it happening, multiply it by 2, multiply it by 2 again, multiply it by 5, multiply it by another 5, and then put this symbol after it. Now, in nature, doesn't that sound a little preposterous or arbitrary? Why in nature, if you tried to explain this to an alien or some other advanced species, how would you explain the logic behind the system that doubles a number twice and then quintuples a number twice, and that's how you describe the form of it, with a new symbol afterward that we now need to include on calculators and computers and stuff? So I think that there are much more fundamental ways that we could have gone about normalizing how you describe the probability of something happening. Unfortunately, we have normalized a system of the percent. It wouldn't be as bad if we were in something like a base 6 system, where we would now be having a pair of 2's and a pair of 3's in what made up a 100. And that seems a little more fundamental, to have the link between the decimal or fraction form and this new interpretation with a symbol to relate to doubling twice and tripling twice, as opposed to doubling and then quintupling twice. But it still would be a little too size dependent, where we're assuming that the right scale to describe probabilities is typically going to require hundredths of detail, more detail than tenths could describe, but not often need something like millionths of detail, because we don't want a percent that we need to write multiple decimal points afterward. If we did, why not have just started with the decimal? And that's just a little rant of some of the reasons why percents are secretly not a very fundamental concept. Doubling and doubling and quintupling something as the transition or the translation between how we would write something with a percent and how we would describe its probability in a more true form is quite arbitrary and a bit silly. Kind of strange that our society is so hooked on it, but since it does come up a lot in life, remember some of those tricks like A% of B is B% of A is A times B over 100, because you might need to use it in our modern society. Hope you enjoyed this little bonus lesson. Remember to check out the main combo class channel 2 for the latest base 2i episode and the upcoming episode about pan-digital numbers, which you can see some of lurking in the background because I'm still working on filming that one this week. And stay tuned on this channel for more shorts, more bonus videos, and more live streams. Thank you so much also to my Patreon supporters. I'll put all of your names in this description. And to anyone who hasn't checked that out, please do. Love you all so much. I'll catch you again very soon.